For my experiment, I'll be trying to determine the contact angle of a meniscus between two horizontal plates using a hanging mass. To do this, my setup will require these materials. I'll be using some tap water with food coloring, and for my flat horizontal surfaces, I'm going to use the surfaces of a coaster and a glass table I have. And other objects I'll use is a mask, tape, coins, and a ruler. As you can see with the picture on the right, I taped the mask to the coaster with the flat face of the coaster facing up, and the mask hangs there acting as a basket. With this, I can add coins into the mask in order to control the weight of the setup. Next, I get ready my water and put some red dye in there so it's nice and visible. And then I pour the water onto my coaster and press the coaster onto the bottom of my glass table, and I try to make sure the water covers the whole contact area and that the coaster hangs properly under the table. And then I would insert some quarters into the mask to add weight to the load, and I would continue to do so until the coaster fell down. And after several trials and making sure that my experiment was performed properly, I determined that my maximum limit was 3/4, and adding more would make my coaster fall. So with this, I am able to take some measurements. First, I measure the diameter and radius of my circular coaster, and then knowing that it takes 3/4 before my load falls down, I am able to take the total mass of the setup with the coaster, coins, and mask, and I can measure the height of the meniscus. I do so by placing a ruler next to my coaster when loaded with the 3/4. When I shine a light through the glass, I can see the red of my colored water more easily, and so I take a picture. And then I run the image into the ImageJ program so I can measure the height of the redness between the two plates, as shown. And with these results, I'm finally able to calculate the contact angle of my meniscus. Given my setup, my experiment can be modeled by the capillary force equation and Laplace equation. Here, force equals area times the change in pressure. The force is the maximum weight of my load before the coaster falls. The area is the surface area of my coaster that makes contact with the glass. And the change in pressure is the Laplace equation for meniscus between two flat plates. So I can plug in my measurements and other properties such as the water surface tension at room temperature and gravitational constant into the equation and isolate my theta. By doing so, I determine my contact angle to be about 70.08 degrees. For my discussion, as I look back on it, there are definitely some things I could have changed to improve the accuracy of my experiment and address some possible sources of errors. For one, the surfaces I used were made of different materials, one being glass and one being part of my coaster. On that note, my coaster wasn't perfectly flat either. I also spent a good number of attempts trying to squeeze out the air bubbles that I could see through the glass in the contact surface area. And maybe I could have used a more gradual method of adding weight to my load than with quarters, as the actual force may be slightly greater than the load with 3/4, but also not as much as with 4/4. Perhaps pennies would have been more accurate to use in this case. And it was also very difficult trying to measure the height of the meniscus. I spent a lot of time trying to position my camera just right and get a good focused close-up photo of the very tiny measurement. And even then, it was very difficult to measure the pixels in the zoomed up image through the ImageJ program. And with all that said, thank you for watching.